So quickly starting, I am Dinesh, and then I've been working in tech for 8 years. I worked at different companies where I've dealt with high skill systems, but more specifically, in my previous company, that company is similar to Uber scale. They're a ride hailing for Southeast Asia. There, it's a customer facing app, and then in that sense, I've seen the applications architecture evolving over time. We sort of rewrote the language stack, and then we moved from non-Kubernetes, adopted Kubernetes. So many architecture evolution I've seen there is what I could say. And also I was managing the DevOps team, and then there we were managing Kafka, which is central to the whole ecosystem. So there also I got a bit of experience with a platform as a service for high scale. Even before then, I was working as a platform engineer. So there we were building services, which is pretty common across whatever is used for the org. And B2B, of course, the scale is different in a different way, but mostly backend and infra, and then I've seen some bit of scale. So in that sense, I'm going to share whatever I know from that context. So moving on, the agenda is we'll touch on production readiness. We'll touch on majorly two aspects. One is we'll focus on a particular service, hey, what you could do, and also when you have to scale beyond a point, what steps you need to take from a whole org standpoint, or the whole architecture should evolve along with the services, and the practices sort of evolves over time in order to adopt for the higher scale. So we'll also touch on that. I'll touch a bit on observability, and also we'll share some best practices at the end. I think if I have to start, the basics is I've seen everyone assuming from a different perspective, when they start, it's hey, whatever I write, it's going to work fine. But as in with experience, what I've learned is it's going to fail for sure in prod. Anything can fail. It doesn't matter what stack you're using, or it doesn't matter what tools you're using. But if you assume everything can fail, and then if you build it with that thought process, you will be in a much more reliable state than thinking everything is going to work fine. So one point I would say is, if there is anything you could take away from this talk, create a doc, call it your production readiness for your team. What I mean by production readiness is whatever checklist you have to go through before you go to prod, or anytime you make changes to your particular service, or anytime new team gets into the org, they have to follow this checklist in order to have a reasonably reliable service or infra to scale to your customers. So make a note of the points, create a doc. Feel free to add whatever suits you, and then for each and every point, you could probably come back, and then we can even have a second session in that sense. Again, this is not a complete checklist, but this will just give you an idea, and then sort of see where you could start with. So the first thing is even before me touching the concepts, assume this is how we start with, right? Any startups or any small companies, they start with a monolith service where, hey, you have a backend. Of course, I've abstracted the whole front end, it could be a desktop or it could be a mobile app, and then you have a database to begin with, and then you serve your customers. I am leaving out of scope, which is you can, there are exceptions like Google, and then some companies which have enough ecosystem and frameworks to use monolith properly, but I'm just going to leave that out for this particular talk. So assuming this as a case, let's go back, right? So in that sense, the first point is single point of failures. And in our case, it becomes super obvious. And then we started with everything being single point of failure. What I mean by that is we don't have any fallbacks, or we don't have any different things to go to when this particular service fails. So assume this is hey, we are saying this is the google.com backend service, and then every other user, every other data related to it stays in that particular database. So in that sense, if any of this component goes down, that means your whole domain or your whole business is going to go down. So from that point, like, how do we start, right? Of course, there is one way, hey, you release everything and then you figure out over time, and then like you try to figure out like what is going to go wrong. And then after it went down, you go back and then see what's the cost and then you fix it. Like that's more reactive way. Of course, we can't fix everything upfront, but there are some approaches we can follow to prevent like our downtimes, right? So from there, it's like we can go step by step. So first is the high level question, right? Like, hey, how do we define high skill systems? Again, it's specific to each companies, but let me put it this way. Hey, your service, you built it for, let's say, hey, you have 100 customers, you have 1K requests per second, but you can almost think like 20x or 30x load, and then you want to build it for that particular case. So rather than assuming, hey, your service is going to work fine for a week, you want to think up a year or let's say even 6 months, and let's say, hey, my service, it should be able to scale for like 100K requests per second or per minute. And then I should be able to scale to, let's say, 100K customers. And then we don't have to, like, we shouldn't break, like the services shouldn't break. That's the one thing. So then how do we figure that out, right? Like that's where the load testing comes in. So it's almost like you imitate the load and then you look at the service and see what's going wrong. So the load testing is basically creating such huge load. Like you obviously know the difference between like Uber scale versus like a small service or a small startup, like which we started like a year back. The load is going to be humongous, right? Like imagine you would have seen Reddit going down or Twitter going down. The amount of posts, the amount of people talk about it is way high. So in that case, there is a metric on throughput. And then you say, hey, I am going to generate 50K requests per second. Assuming like after 6 months, like we'll be having something like 30K requests, and then we start the load rate. So we define the input, and then you look at your system, and then you see, hey, what's going wrong? Again, like the second part I've left out, right? Hey, how do you know that like your service is gonna be fine? Let's say if it panics, if it like sort of throws a null pointer exception, or if it throws crashes, you don't have any data to say, hey, this is why it failed. So that's where the other part comes in, where how do I make my service observable? And then also like what metrics do I look at? And then also like following practices to sort of prevent that by happening, like when you go to like prod. I haven't involved everything, but let's start very simple things, right? Like obviously you have to have good logs. What I mean by that is like we are talking simply about HTTP APIs. It could be gRPC. You can sort of translate it to everything. So in that sense, you have to log performance metrics. You have to log some status codes to begin with. So that way, when you go to prod, like you can see what's going on wrong. Let me quickly show you something. I mean, I'll give you context on what it is, but you can just see, right? Like there is I sort of did something here, but you can see, hey, what is the API and what is the status code? This is like Nginx logs, but this is something you have to have, but you need to add additional metadata to sort of make it like observable. Like when I say log ID, the one reason I can say is, we haven't touched on the multiple services, but it's like when a request fails, you have to know why that particular request failed. So in that sense, you can go into logs and then sort of tail or grep for that particular ID and then figure out what's happening. Obviously, like again, these are all high level, like add testing, start with TDD, you add unit tests, you add like service level test, and then you add like contract test. And then like to an extent, I can also say, hey, every team or every company could define, hey, this is the test coverage we should be following before we go to prod. It shouldn't be like 50% or something less, but rather if you have an 80% coverage, or ideally it should be higher, much higher, but just as an example, let's say 80% of coverage, that means whatever failures or whatever changes you have done over time, You don't have to have a manual tester and then recheck it every time. Like if you have more tests, you have more confidence to change things. That will also enable us to deploy or develop faster, right? So this is like just simple, like if you write a simple backend service or a simple Python service, right? Like just starting from there. But let's go here, right? Like let's touch on few things and then come back to the concepts. So one is, here I've denoted like this particular service being read. So since we talked about load testing, I'll share a demo at the end, but when you create a load and then when you observe this particular service and then you sort of see some degradation or like some performance bottleneck in the system, you have to scale your like a monolith to adopt better. So in this case, let's say, hey, your service is not able to serve beyond 10K requests. So initially our objective is to like serve 50K requests per second, but it's starting to fail at 10K requests. It could mean like status code failures, it could mean crashes, it could mean like running out of resources and stuff like that. But obviously what I mean by this red particular thing is like, hey, here it became a bottleneck. So then what you do is like that's what we go as a next step, right? Like replication or creating multiple instances across your system. So in this case, if you had a single backend service saying like user service, you need to create multiple services to serve better, right? So assuming our same case, our service is able to serve 10K requests. Now this will be able to serve, let's say, 30K requests. So the bottleneck will sort of spread from just being on the single service to some service which has load, has a bottleneck, but overall the services become healthy. Of course, like you can translate this to, I need 5 replicas to scale it. I mean, we'll not touch on we'll touch on the scaling based on throughput at later point with like Kubernetes or some sort of tools, but in a high level, you have a single point of failure with respect to service. This is why we end up creating multiple VMs or multiple pods, and then like create multiple instances of the service. So that way, even if this service goes down, you sort of you can do your business with like the other 2 instances. But since we sort of mentioned like, hey, assume everything and fail, it's almost like I can say this, right? You're not really solving the problem, but you're just moving the whole bottleneck or an issue from one point to other point. So what I mean by that here is like here, rather than your service being a bottleneck, now after a while, your database will become a bottleneck. For instance, let's say if you're using a Postgres database, if you have a connection pool, you would have just started with, let's say, 30 to 50 connections. And then as and when you do load testing, the service was breaking. Now you were able to scale your services perfectly fine. Now the 50K request is going through, but your database is not like scaling up. And then you will face issues like two things, right? Majorly, one is performance. The other one is like crashes. Performance being if you have too much data or your data is so high, and then you try to query count of particular orders per day for a particular driver, then the latency would shoot up from, let's say, 5 seconds to 20 seconds or something like that. Ideally should be MS, but just saying it could go to 3x higher. The other point is like, hey, if you have connections, the connection pool itself is not sufficient because like obviously it's tied with logs, the queries you have and all of that, but the database becomes a single point of failure. So now what folks do is we create a replica for that. And then like, again, when we say replica in terms of services, the service 1, 2, 3, all of them were same. it shouldn't have actually any state associated with it. When I say state, it's like a user records or users, like internal order status and stuff like that. The database actually has it. And then when you say replica from a database perspective, if you have 100 customers with like each of them having 500 orders, like that exactly maps to the other replica. And it's almost like both data is same, but the replica is not meant for like writes. You write everything in your master, and then it's almost like you take away like the rest of 30K requests, which is reading, and then you put that on a replica. So if you think of it, most of the times, like if you're hailing an Uber, the order creation ratio is very less in comparison with, let's say, order status or order details, because you will be keep on checking, hey, do we have a driver? Where is the driver exactly? What about my status of order, like how far he is? That throughput is way higher than the number of orders you create at a particular point of time. And then if you sort of extrapolate this, if you have 100K users, the 100K order creation is going to be just 100K, like if everyone creates a particular order, but all of them, if they check status and then retry, it's going to be like a 500K or 1 million requests per second. So that's why like moving reads and writes separately sort of helps mitigate the database being a bottleneck. Again, like we've sort of touched on like only single service perspective till now, like assuming all of this, like this particular monolith service is actually doing order creation, users, auth, everything, right? So now sort of like answering the other question, right? Hey, your service is fine now, your database is fine now, but who's sort of dealing with the failures and who is sort of helping you distribute loads? What if you have 3 services, but like you only create DNS, and then if the DNS points to like all like bunch of services, but like the DNS is not exactly a load balancer. So here, I mean, we didn't talk about load balancer. Like the load balancer responsibility is to distribute your load across services. It's not going to be like exact percentage, like it's really tough in a computational sense, but you can say, hey, 30%, 30%, 30% load is distributed across all 3 microservices, all 3 replicas of the services. So that way, the load balancers ensures distribution of throughput. There is also other thing which the load balancer sort of enables us, which is whenever a particular service sort of goes out of, like goes into unhealthy state, it's the load balancer's responsibility to serve traffic only through serve this particular healthy services. So if you say, hey, this is service 1, 2, 3, if 1 goes down, the traffic will be only going to, let's say, 2 and 3. That's more from service discovery or like some sort of health check, and then the load balancer sort of enables us to do that. So that way, like the failures is not going to happen through a failed service, and it's sort of load balancer's responsibility. This is again just scaling it in one level. I mean, if you think of it, like obviously, if we do enough load testing, and then if you do more and more, the load balancer could actually become a bottleneck. For instance, if you're using, let's say, an Nginx or any self-hosted, let's say, a VM, that particular VM has different point of factors to look at. Like it could be network, it could be file descriptors and a bunch of things. And you also have to ensure the load balancers is fine. So initially, when I said the load testing, you could get away with just hitting your backend and then test it. But now you can't just hit backend, but you should be hitting load balancer, then test it. And then when it's almost like one statement to sort of remember, right? Try to keep your state of things very, very close to production. What I mean by that is it's not just architecture, but it's also data. Because if you do load testing with just 10 users in your database, that is not going to show you a better representation of the load testing and then actual metrics which can happen in prod. So it's almost like try to keep your architecture exactly same and then try to keep the data very close to the level of data which is going to be in prod. And also there are some bunch of tools like which is there, like we'll touch on it, but and then that's where like the whole having different environment comes in, right? Hey, this is going to be my staging environment where I'm going to do everything. Prod environment is where I'm going to deploy when stuff is fine, and then that is only serving users. So sort of going back here, now we said, hey, we'll do load testing, we'll do proper logging, we'll touch on metrics, but like circuit breaker to prevent failures, like we'll talk about it like once we touch the high level architecture. But this is how you go from like step 0 to step 1 in terms of scaling. And then like this is a bunch of tools which is going to help you do this scaling. Like, hey, how do I create X number of service instances? Like Kubernetes sort of helps you over there. HA proxy is really a good load balancer, and Nginx is a brilliant one. And then obviously GLB and then AWS has like a bunch of load balancers there. So let me just see, like, I don't know whether we have any good questions for me to stop, but I can jump into show that like exactly like what like how we are talking about this process. Like we can actually try to do it now. So as we said, hey, we're going to pick a sample which is Nginx, and then I'm going to define like this is the example, right? Like, hey, we are defining like 3 servers. In this case, like this is just a documentation, but I have defined 2 backend services in my my machine, and then there is an Nginx running, and then like we're going to use that for like load testing. And this is just an, sorry, go on.
It looks like we have question. Marcus raised like his hand.
Sure. What is the question? Which question are we talking about? Sorry. How to best deal with replication load balancing between different regions? The replica gets writer. Just a second. Testing.
So we have an issue with, I mean, we have a topology which has a segregated master database and then one replica with 2 more nodes. Is have you taken in mind, or have you made a practice with the three services that can write to 3 databases at the same time, so that they also replicate in a load balance? Instead of just having
but sorry, go on.
Yeah, so is there a way to also replicate, instead of having a replica with 2 services, is there a way to also write and not segregate the master and use the replica in the same way? For example, here we have a segregation of the master and then a replica from other 2 nodes. So have you had any implementation in which you just write everything, in which everything is connected? Say the first service goes down, what's going to happen with the replica?
Correct. Okay, gotcha. So let me just add a little bit more context, and then I'll try to answer that, right? So one is like for everyone's context, the replication between databases is the database replica's responsibility. It's almost like you're defining a master-slave architecture or a cluster from a database concept, and then all the replicas is going to get the data from a master database. With respect to the services, the question is, hey, why do we even have to segregate, right? Like I didn't touch on, let's say, reading URLs, paths, and then redirecting traffic. Like imagine what's going to happen if you try to do a write on a replica. It's going to fail because the replica shouldn't have writes. So now it's almost like you have to split your API, like as a service. If you have 5 API, let's say order creation is write, but order status and driver status, all of that is read. And the write should be going to a master service. So in this case, I have only abstracted, but it's almost like you should have multiple master services and then multiple like services, which is reading from slave. It depends on traffic, right? And then this particular service itself is highly available now. So it's not going to exactly look like this architecture, but rather you're going to have a load balancer for only write services. So the service which is going to be writing it will be talking to that service, and you will have multiple instances. So you can imagine 3 services, doing order creation, talking to master, and then load balancer, and then like the write requests are redirected to the master setup alone. And then there is a different setup where the reads is going to be higher. There is a different load balancer. Like imagine the same setup, but like for a read-only service. And then that could be like a 10 instances, because the writes is less. You will have 10 instances of your services, and then you can have like 3 to 5 replicas based on your load. And the traffic redirection happens from load balancer. The load balancer sort of supports like ingress rules and stuff like that, which enables us to do redirect traffic based on some rule like, hey, if the API path is this, redirect it to master. If the ID has something like this, you can redirect to that particular master and stuff like that. We'll touch more on this architecture, but having said that, like now, I mean, again, which tools to use is up to you. Like there was Gatling long back. I personally like work too, which sort of backs with some Lua context. Vegeta is a good Golang thing. I'm a Go enthusiast, so I might be showing you Go services and like Go related tools and stuff. And there is K6, I think, which is backed by JavaScript. But all of them enables you to do just simply one thing: hit an API with a defined number of requests in a particular time window, and then it can collect some sort of a report. So let's go to the demo, right? Like sort of a demo. So what you can see here is like this is my first service. This is my second service. And then I sort of have an Nginx, like I'm just tailing the logs here. And then I'm going to use Vegeta tool. Like that tool can send bunch of APIs. And then I'm going to use a different tool as well. Like I'll share more on like why I'm doing that. But I can also show you what I ran. So it's almost like this is what I ran. You can see, right? Like, yeah, I hope it's visible. Yeah, so one pane, like I have a load testing, I'm going to run this. Another pane, like I have a make build, and then I'm just sourcing some env variables, and then I'm running an API server. And then here also I'm running an API server, and then here I'm just tailing the logs. So that's what we were doing here. Just a little bit more context, right? In order to have a better representation of our load testing, I sort of created a like a configuration to say, hey, if I give a particular value, like pick up a random number within that and then wait for it. So as you could see here, like this is my 2 services configuration. How I'm differentiating, like, hey, I'm running on 8080 because it's local. In your case, different VMs, it's not going to be different. But one service is running 8080, another service is running in 8081. And then the 8080 service is like the service 0. Let's define it as service 0. And then it can wait up till like, let's say 10 seconds, but the other service is always going to respond within like, let's say 3 seconds. And I can also quickly show you, I hope it's visible. So I'm going to say, let's say, ping, and then I'm going to define 8080. And if you could see, I mean, my server 0 is on the right side. This is always going to this particular pane. And then here, 8081, I have this other service. And then where do I have Nginx running? This is my Nginx. And you can see like the logs are going through this particular pane. And then it could be going either to service 0 or service 1. So having said that context, I'm going to run Vegeta. Like, don't worry about the tool. All I'm going to do is like I'm going to run bunch of APIs. Like here I've defined like users, user count. I haven't even told you which particular API actually has that sleep. And then let's run this report, right? So I'm just going to run it for like 2 minutes. So this is what I was talking about, right? Like here, I'll just give less numbers for representation, but you have to define like, in prod for a minute, I will be getting 100K requests. or like 50K requests, like we said. And then we can also add timeouts, because that way you sort of enforce how much time each API is gonna take. And then I'm done, right? Like, so now if you go and see here, it's flooded with APIs. Of course, like there is a lot of things I did, like it might fail because of descriptor limits and all of that, but you get the idea, right? Now I'm able to do load testing. You'll be doing the same thing with your staging service. So now I'll just go back to a different thing. So now how do I know what's happening, right? So I'll just come here. I hope it's visible. Can you see my Grafana dashboard?
Yes, we can see.
Is this visible? Like anyone, could you just confirm?
Yes.
Yeah,
Yes.
we can see it. Yeah.
Okay, awesome. So we'll talk about like what sort of metrics we need to capture, but as you could see here, there are some metrics. Let's keep it running for a while, but let me talk about the data, right? Like in the top, what you see is latency heat map. So basically the heat map is a distribution of, hey, how many requests falls under a particular, like a window, like in terms of, hey, within 5 to 10 seconds, how much requests are falling, under a few ms, like how many requests are falling. That's the heat map, like latency. And then this is average. Like I'll touch on like how is this different than this? This is average latency. If you have 10 requests per second, what is my average response time, summing up and then dividing by 10, right? Like very regular one. And then this is my throughput. And then this is my throughput, but associated with the status code, because if I see all the requests, and then if you don't have a reference to status codes, you can't differentiate, hey, how many are 401s versus how many are 200s? And also like some are resources, like we'll touch on it later on, but latencies and throughputs with status codes. And this is what we talked about, like when we said metrics, and this is what I'm going to observe. And then I'm going to say, hey, after running this load testing, yeah, like, I mean, ignore this connection resets, but it's like, you will have in a report. And then if it says like, how many failures are there, how many, what do you call that? How many 401s are there? Then you're sort of good. Like mine is majorly failing because of view limits, but assume like you will have a better setup and then like you will be able to see the report. Then you see, hey, how many failures are. So that's the steps. So let me sort of go back here and then like jump to the next step. So it's just a sample representation, but like what this report gives is very, very minimal. What you were seeing is actually Grafana. Like there I created a bunch of dashboards. And this is something which would be much more useful to you, right? Because it's not just service metrics, but you can define like, hey, orders created per second, or you can see, say, payments created per second. You can also define, let's say, some business metrics, and then you can track that. So that is that metrics, but I'm mainly focusing on like, let's say, non-business metrics at this point. So once we have done that, we will have a better understanding of our service. So here, let's go to this particular window, and then I don't know how much of it is visible, but as you could see, we talked only about like some bunch of APIs. And then I've also added proper labels. So let's just say, I'm only talking about service 0 now. And then as you could see, the /users is taking up a lot of time. The ping is usually fine. Like ignore the seconds. Usually it should be under ms. And then the ranging is sort of affecting us. And then here you can see service 1's data. And one interesting part is like here, if you can notice, like the average latency is way under, let's say, 10 seconds. Like forget about the like initial boot timing, right? But here, if you notice, it's all under, let's say, 5 seconds. But if I go to the heat map, it's saying, hey, I have a bunch of requests, which is in 10-second window. So that's why like percentile is actually bad, but I mean, sorry, better than average. the average is usually bad, and then it's not a good representation of how your service is responding to for all customers. I'll give you an example. Like if you have 100 customers, if 90 people, they take 10 ms, but for 10 people, it takes, let's say 10 seconds, your average is still going to show you response time in terms of ms. But if you say, hey, what is my 99 percentile? Then it's going to tell you my worst case is like the last value, which is like, let's say 10 seconds. My 99 percentile is going to be, let's say, like 7 seconds and 8 seconds. And then you have to optimize for the percentiles. And then now if you go back here, like that's what I mean by, let's say, like 99 and 95 percentile and then 99 percentile. Like it's still same, but if you do enough data, this is going to be very different. Like for your case, like as you could see, like I've just run on some time, but if you could see, like the 10-second is over here, but over here you don't see the data at all. Like the average is way lower, and then it's not a good representation. So that's one takeaway. Now let's come back to this report. Okay, again, I don't have a great report, but what the report is going to show you is number of failures, what is the distribution of latency. It's the same thing, but it's going to show you in a matrix format, nothing else. So now moving on, right? Like that's where the observability comes in. Like we talked about metrics, but in terms of like as you scale, your services needs to be observable. So that way you can exactly tell what's wrong, where it went wrong. And this is not just for like load testing, right? Like going before production, but let's say you go to prod and then something went wrong for particular customers. How would you know that what went wrong? So that's why you need to have observability. If you don't have observability baked in, you go live and then your customer sees an issue, and then usually they're going to call you and then say, hey, you know what, like this is failing. I mean, in startup case, like it's that way, but like in terms of big organizations, depending on the observability scope and then how much you have covered, the failure might not be like so evident if your service is not observed. So let's go back here, right? There are multiple components. So your load balancer could fail, your service 0 could fail, 1, 2 could fail, your database could fail. So in that sense, we have to measure throughput for every component. Your load balancer will be like 30K requests. Each service will have like 10K requests each. And then let's say for some reason, this particular service started showing failures, your dashboard should be able to tell you, hey, my service 0 is actually responding slow. That's why the whole response is actually failing. So now let's just go back here. Hopefully I have some better data. Let's say last 15 minutes. And then I'm just going to go to, let's say, the average latency, it's fine. But if you could see here, the users is the one like which is taking time. And then I'll show you the code. So basically, I had a users API, and then that is where I had all of my, that's why it was taking much more time. Like I had a sleep time, which is injected in a users API. And then, yeah, you can actually see here. Yeah, the users is actually mapped to list users, and then that's why it's failing. And then I don't even have to say it because you can sort of observe it from this particular place. Because the moment I disable users, you should be able to see the response times are much lower in the whole left axis. So yeah, coming back. So now let's say, hey, we do this load testing, right? Like there is one other interesting bit, which is what kind of APIs I have done load testing for. And then if you notice here, I have some valid auth. So I've sort of given one user ID and then one password. And then I'm just going to say, hey, keep trying auth for this single user. But what this doesn't represent is basically some sort of leaks. Like, I mean, like there is a section we'll talk about it, but you have to do load testing with dynamic payloads as well, because like I have some code where I save the count of each request for a user. And then if you have a single user and if you do load testing, We haven't even touched on caching, but it's almost like that is not a good representation of your production. So in prod, you will have 100K users. So in this case, you have to have very different kind of users to have a reasonable representation. So let's go here, right? So now this is heap. This is basically a memory allotted for a service. And then as you could see, the number of allocations is somewhere around 320 KB. Even if I do this load testing for longer, I sort of did it earlier, it's not going to increase. But let me try something else, right? So I'm going to try something called DDoS. That's a different library I was able to use to generate payload. So what I'm doing here is, hey, do the auth and then do 10K requests for a minute, and then generate a random payload. That's what it's doing. Hopefully this doesn't crash my system. But if you could see here, I mean, you're not able to see the actual body, but all the auth, you're able to see 401s. And then let me just go and show you a bit of code, very small, but don't worry about anything else. But I have a rate limit logic. I mean, we'll talk about what it is, but it's almost like, hey, you want to prevent a single IP from hitting you and then making your service fail. For example, there could be one bad bot or one bad user who wants to bring down your service, and then I can keep trying. It could be auth, it could be get my order status, but I can flood your system because I have the credentials, and then I have whatever I need, API tokens. But let's say, hey, if it goes beyond something within a minute, I want to drop it. There are a bunch of tools which will enable you to do it. This doesn't sound crazy, right? This doesn't sound crazy when you look at it from the code point of view. But now let's just go and then see for a while. I mean, we'll keep it running. But the point is, what you're going to notice is the heap usage is going to increase a lot. The reason is it's almost like I have a data of key, and then the key is basically user ID. But what I'm doing in this case is generating random data, right? For every user. So in that case, it's going to fail your, sorry, just a second. Let me just, I mean, ignore whatever details, but load testing with a very random ID is going to create your memory to be leaked. So, I mean, don't worry about this. This is just a key value pair map in Go. But the point is, if you have one key, which is always changing, or 10 users, which is always logging in, and then you're increasing the number, that's very different than you having a million keys, and then the million key actually translates to memory. I probably I want to sort of leave it for the end, but this is still sort of linked. And then it's sort of interesting to note that when you do load testing, if you don't do dynamic load testing, and then if you don't look at the resources, you can have leaks. And for that, I think all of us, we would have done it in our experience. It's restart it. Restart your service or restart your backends, restart your load balancer or restart your cache, whatever. But that brings it back to zero, but it'll take really, really hard effort to figure out where it's happening. As in when you scale to multiple services, multiple microservices and whatnot. So the thing is, we'll touch on what it is. If I have time, I'll show you the pre-prof. But Golang has this nice tooling around it where when I do some load testing, it also traces my, profiles my view, and then sort of figures out how much memory it takes, how much CPU it takes. And then it almost tells me immediately, hey, there is something called users authenticate. And then there is something called users rate limit. Within that, you're taking 22% of the memory. And then this is not even days of load testing. This is just few seconds of load testing. And then if you go here, hey, I have authenticate, and then I have something called rate limit. And then, yeah, here is the culprit. I mean, this sounds so simple, but I think for microservices context, it's going to get complicated much more. Like I'll share it in a bit. So I hope it's connected. Like the load testing, I think we can close that point, right? Hey, you imagine your service is going to serve this much users based on the throughput. You do load testing to imitate that kind of environment in your staging. And then you have good enough logging, good enough observability using some sort of a InfluxDB, Prometheus, or anything of that sort. You define what metrics is important to you. And then you do load testing, and then you see the report, and then you observe. It's good. If it's good, then you go to prod. If it's bad, I will not let you go to prod. As simple as that. So now moving on, right? This is only from a single system point of view, like single particular service point of view. What's going to happen when you scale to multiple microservices? What's going to happen? Like why there is a need for all these event-driven systems and all of that, right? Even this particular scale is not going to help companies once you reach like a different kind of scale. So for that, after some particular time, like be it a year or two, you keep scaling your service, you keep throwing more resources at your services, you can scale to an extent. But yeah, tools can come in handy to an extent, but after a while, you have to really relook at your architecture or change or adopt your architecture in a way that you can scale for multiple countries, you can scale for like, let's say Amazon or Uber kind of load, right? That requires a very different effort. Like this is just like, let's say level 1 we touched on. This is a different thing, right? And this is again, like this might not be one solution for all. Like every company would have done different evolution over time, but it's almost like you can take some takeaways from the conversation, hopefully. So one is you really have to look at your architecture and then say that, you know what, like these are the hacks we've kept and then we were okay with it. Like imagine you don't have a cache for a particular source. Ideally, if I keep on checking a report for a driver payment, I can cache their data, right? So introducing cache or introducing, hey, this particular service should not be a monolith, but rather microservices. And then stuff like, let's say, leveraging worker kind of tools or even Kubernetes, even like RabbitMQ, Kafka and stuff like that, right? Like we'll touch on like why it is, but the point is you have to look at your existing architecture in a board and then go back and then figure out this could be a bottleneck from a whole point of view. Initially, it was single services, but now it could become like, hey, there is a payments team, there is a users team, there is a drivers team, and then there is like some kind of a promotion team, and then each team has their own stuff to look at. So that's where we'll be talking about, right? Let's take an example here. Very simple, right? Ride hailing, or it could be food delivery, any delivery services. The flow is like this, right? Like, hey, you create an order, your order status gets changed. Like when I say status is from created to driver being allocated, from driver being allocated to driver being like in transit, then delivered, then payment completed. So basically multiple state transition for orders. And then you have a driver pickup. It means like there is some other drivers who you need to notify. And then like there is some other place where you need to get driver location, right? Like you also want to know what is the driver location and then pay the driver. So this makes sense from a domain point of view, right? So now let's talk about this. So initially we had monolith service. Like assume whenever I say, hey, this service, right? This service is a multiple replica. This database is a multiple database. This single component represents whatever like scaled component where we talked about. Now we are just abstracting it. So now I think that was itself was a question, right? Why do we need to split services, split microservices, right? One quick example here, right? Get my orders is like 500K requests per second. Your create order is 10K requests per second. It is like 50 times more, but your service is not scaling. What you do, you throw more VMs and more load balancer to it to accommodate your worst API. In this case, it get my orders, right? So in order to accommodate 500K requests per second, you keep on scaling from, let's say, 3 service instance to 30 instance because your get my orders needs that kind of a load. But in reality, what you could actually do is split that into two different services. Your order creation, or let's call it, let's say, I'm just saying, let's take a different example of like customer has less throughput, driver location has a much more throughput, because if you have a 50K driver, all of them keep on sending locations at any point of time. That has a way higher load than your customer service. So splitting these two into two different services will give you an advantage of scaling your resources appropriately as needed. So what that means is like you will have less cost. You don't necessarily have to scale one thing for the worst API. And it also gives you a different benefit of splitting two databases, right? Like, I mean, of course, this is database with replicant and all of that, but it's better to have like two different things than a single point of failure, right? So now the data ownership is also split, and it also enables you to build a team around it. So when I say, hey, you know what, like let's add a new order status, the only customer service have to be deployed, but you don't have to deploy driver service. So that means the deployment is also affected, right? So all of this factors sort of helps when you talk about like microservices versus monolith. That is an interesting conversation. So, but super high level, you can scale independently with respect to throughput, with respect to deployment. Teams are independent. Data is super important, but like we'll touch on like why, right? So in this case, as you could see, initially it was a like monolith service. Now the load is sort of split into customer service and driver service. So now what's the problem, right? Like again, you can reach a point where your driver service is becoming a bottleneck. That's where you adopt or like start looking at event driven systems or like a pub sub architecture. There is more reasons to adopting it, but let's say I'll give you one example, right? Hey, we keep on saying adding features for customers once the order creation is completed. For example, I can give you points, give ratings, give me a promotion, generate a report. All of that is a feature, but if you think of it, all of that have to go in a single customer service. And then the code is grown, the number of APIs is grown. It's not just like a split in a domain context, right? Like when you think about a service, you think about data modeling and whatnot. But when you think about like the whole service architecture, initially you started with a single customer service, but in reality, now you're in a place where you can say, hey, I have a driver service, and then I have a payment service to deal with payments, because payment is much more critical. I want to make that service much more reliable. It's fine if your order status is going down for a while, but my payment shouldn't go down. This kind of pub sub will enable you to do that. There is also a lot of like other benefits, like what if the service stops and then the users are sending some payments. In earlier case, if two orders are getting created and then if my driver service is down, your orders are lost. So basically you're losing business. But now in this case, it becomes an asynchronous architecture, and it also becomes like an eventually consistent architecture. Like these two terms, you can go and read about it also. But even if your payment service is down, the two orders is going to go through, but the driver is going to be eventually getting the payment, rather than like why should a customer order be tied to, let's say, a driver service being up, right? I can also say that, hey, pay the drivers at the end of the day. But initially you wouldn't be able to do such things. But now with this architecture, you can sort of leverage not just scale, not just domain specific thing. You can also like build architecture in an extensible way. So another example for extensibility, right? Like all of this is done. Now I'm asking you to create a report generation service where, hey, every day you have to tell me how many orders are created. Every day you have to tell me each city, how much money is made. Every day you have to tell me how many drivers made, how much money. Why would I go and add that in a customer service or a driver service, right? Like imagine if you're building a report, you would have to go and fetch customer data as well as driver data and then build that report. And then you are adding more and more load to it. But if you have an event-driven system, what's going to happen is there is a single kind of a store. Like again, it pops up, like the Kafka is a store. Like, well, let's take an example. Kafka is an event pub sub architecture. The Kafka is going to have every message whenever I create order, anything which is going to happen is going to be reflected in that system as an event. And then I can have 10 people using that event and then do something, or I can have like 20 services, or I can have multiple teams using it and then build whatever they need. So in this case, when I want a report generation service or a team, all they have to do is consume from this particular PubSub. They don't have to touch anything. They don't have to rely on anything. So that gives us a lot of leverage. So and that's what I mean, right? So now this architecture can scale from this to this, and then nothing have to change from customer end or user end. Of course, we haven't talked about bottlenecks and data and all of that, but assume the extensibility and scalability is much more like it can take you a long way with this kind of architecture. I'll stop here, right? I'll sort of stop here. I'll stop here and then take questions with this architecture, because there is some few terms we can just mention, and then we can talk about we can talk about it. Let's go back here, right? Sorry, I keep on switching multiple things, but it's like the replication makes sense. Every component, whatever you have in system, at one point, it becomes a single point of failure, and then you have to replicate it. Services, databases, load balancer, and the whole set of that service have to be replicated. Now you can think in another level, right? Imagine this is one representation, but each service itself is already load balanced. What happens if you have scale across countries, right? So now the replication sort of makes sense from country perspective. Put it this way, right? Like the data, if you have the whole country's users database in a single data, it's going to be terrible, right? Like, you're starting in a new country, but they also have to face so much latency because you are using a database which has US data, like every US user's data. And then you created like a Canada data. And then like the Canada users have to scroll through, or like in terms of query, I'm saying you have to look at the whole data to respond to them. And then like if something crashes, your business, your services is not available across countries, right? Like not just in one place. So what do? You replicate across, even before countries, you replicate across regions, zones, and then countries, right? Like, like it's almost like, let's say AWS or GCP, you create service instances, and then this service itself is abstracted, and then you have to. That's where you would have heard zone A, zone B, zone C, and then from there, like this is like a US West region, and then let's say you can even replicate it from like US East region, and then this setup, the same thing is replicated for Canada if you're going to it. This is almost like, hey, what if your whole data center, which is available in a particular US East region, goes down, right? And also like people sort of want to keep the services very close to users. For instance, like we are scaling to, let's say, somewhere in Southeast Asia. Why would you serve your request from US? Because you want the data, you want the responses to be fast. So you would host your application and the whole setup stack in Southeast Asia, wherever it's closer, like wherever you need to be closer to the users. So that's replication. It applies to every component, everything, architecture, even your company, you're replicating across multiple countries. So that's replication. So sharding is a bit of interesting thing, right? Like now, let's say, you would have seen Amazon sort of have created like a different kind of URLs, Amazon.com and Amazon.ca, and then like based on the domains you serve traffic. But like let's say Google.com, or even let's simplify it, right? Like what about cases where you want to have data only in that region, right? Like for instance, like same case. Like, don't worry about like, let's say the domain being different, but assume that I have a particular service deployed in US as well as in Canada. And then I have a single domain, like which is like google.com. And then when users comes to it, if they are from Canada, it should go to the Canada services. If they are from US, it should go to US. And that's the concept of sharding, right? Like it's almost like you have a request coming in, you can sort of partition it. There is more reasons for doing it. Like it's not just latency. there is also a different reason, like, hey, let's say your database becomes an absolute bottleneck from a single service point of view. You have millions of customers. What can you do? Like, I can't split this as a different service. It's still customer service. I have a million customers. So what do you do? Like, you can basically create service 0 and then service 1. And then you can say, hey, even number of customers will be served here. Odd number of customers will be served here. Or you can say, like, you can do it by region. You can do it by some category. But the point is, that's what I mean by partition, or let's say, like some sort of segregation for customers. And then you redirect to, let's say, Canada, or let's say, US region based on it. So in this case, it could be as simple as you have a different ID format for users, or let's say you take location, right? Like, let's take a request. You will have a user ID, you will have some auth token, and then you can also have some IP address or location. And then based on the location, you can redirect traffic, just like how we said, you can redirect traffic from load balancer. The load balancer also allows you to partition your request. So what this enables us to do is, now it's not just master and read, which is partitioning, but it's almost like, assume these two are like same services, but like if I have this ID, it goes to this particular place. If I have this particular ID, it goes to the different service. So the sharding sort of enables you to do, it's almost like you're cutting the data, not just services. So rather than you holding 500K requests, 1 million requests and 1 million customers in a single database, you're going to have like 500K users in a service 0 and then 500K users in service 1. You can also do it like 300K each service, and then you can do one mod tree for requests and then do it. So sharding is really interesting. Like, we've done it once for some like optimizing performances, but again, like, this itself is a very interesting topic. Sharding is applicable in database. Like, there is some table partitioning, service levels, and then overall your architecture. Like we talked about region wise, it's also applicable there. Load balancer, I think we touched on it. Yeah, so event driven system is what we said about, like, let's say Kafka, right? Using Kafka. But there is also one other point, like I mean, I didn't add much into it. But an example is, we said assume everything is going to fail, but let's say when you create an order, it can fail, right? So what you end up doing is you add retries, and then you add some kind of a workers, like, which is like a RabbitMQ or something. Like, for an example, if an order is completed, if you want to pay a driver, you don't try once and then fail immediately, but rather you keep trying in the background. That's why you would have seen the payment is still pending, but in reality, they might be trying it asynchronously, right? So retries are awesome, but be cautious. Assume that if it's going to fail, it can fail forever. So you need to have some sort of a timeouts, exponential backups. Like, I haven't added it, but you can literally take down those things. Keep timeouts, use worker model, add appropriate circuit breakers, right? Like, now it makes sense here. Like, assume the event pub sub is not here, but without pub sub, customer service will be calling driver service will be calling, let's say, customer service. And then imagine if you have 5 services without event driven architecture, it almost becomes like a mesh architecture where the data is going across everywhere. And imagine if a single service goes down, all other microservices goes down a lot. It sort of cascades the failure. So that's what I meant by I mean, initially when I mentioned here, circuit breakers, there's 2 points to it. One is, if one service fails, it shouldn't bring down other services. So what you do is you give room to other services. For an example, OTP, if it fails, we don't wait for it. Every customer is going to do retry. So if your load is 5K, it's going to become 50K, because if everyone is retrying. And that doesn't leave room for services to come back or recover from resources. So what you have to do is 2 things. One is, if one service goes down, don't even call it. It's fine. Like, for 5 minutes, you're going to fail, but don't call that service. So what that also means is, like, you need to be okay with partial failures. If sometimes you're seeing an order status And then if you are not able to see, let's say a driver, not even driver, let's say a car information, why should your order status fail if your car number is not visible because of some car service being down, right? So you should be, not when I say you, it's like your services, all other calls should be okay with partial data and partial failures. So in this case, if you have a bunch of calls to make a particular order, if one thing fails, you should be okay with that particular thing being done in asynchronous way. For example, like payment or generating reports, like, yeah, simply put, data science operations and reports, right? You can associate, it should not affect any of the transactions. So that way you can say, hey, if any failure happens there, just retry in an async way, right? So in that sense, right, like when you add retry, like I mean, I've added in the end section, there is a concept called Byzantine generals problem. Just go read about it, it's brilliant. And then when you add retries, there is this question of, hey, if I have an order, there is a payment, and then what happens if I retry? And then what happens if both of them went through, but only the response failed? There is all this question of redundant payments and dealing with redundant requests and all of that. The only thing I would say is you cannot ensure only one semantics in a distributed system, or say that, you know what, like if I send one request, there is no way to ensure in a whole org it's only processed once. So every service have to assume, hey, this could be a second message. So it's almost like, hey, did I pay the driver again already? If not, don't pay. Stuff like that. That's what I mean by, like, it's not just the idempotency doesn't just like, what do you call that, fit services, but it fits the whole ecosystem. So your payment service should be idempotent. Your customer service should be idempotent. Because in event-driven systems, it's possible to not only have redundancy, but it's also possible to have out-of-order events. So this is another point, right? Like I don't have slides for it, but it's like, as in when you adopt complex systems to help you, those systems is also going to bring in additional responsibilities for you to deal with it. If you throw in Kubernetes, that doesn't mean it's going to just help you right out of the gate, but you also have to ensure the Kubernetes cluster is up and running. If you use Kafka, you're going to deal with redundant data, out of order events and stuff like that. You can't have like timed messages. Like there is no way to say when the message is received and all of that. Allow system-wide partial failures, build async systems, but coming sort of back to initial points, right? Like have sensible timeouts, like assume every service is going to fail. Don't just wait forever. Like, I don't think like people will think about like timeouts in a one service, two service context, but the moment you have so many services, let's say a driver location service returns like data in 20 seconds. Why would a create order have to wait for 20 seconds? Just fail it immediately. Don't, every request you make, you should have an answer on, I am not going to wait beyond 1 second. I'm not going to wait beyond 500 ms. Retry. If it fails, retry. Even if that fails, use a worker. Even if that fails, don't stop processing. Put that in a dead letter queue. If you tried it 50 times, how can you say that it's going to work at like 51st time? So after a while, like you have to decide whether it's 50 or 30 or 10, but you have to put that in a separate place so that you can even do manual intervention, right? Do enough testing. Backward compatibility is again another topic of its own. If you have written public APIs, you would know like there is no way to ensure all customers uses the same version of app, right? Any user can be on a different version of app. So that means your API, you can't break contract. If there is 100 users who's using user ID field, you can't suddenly change it to ID. It's going to break. Use rollbacks. Always assume system is going to fail. Always have a backup. If you're releasing, let's say V3 and then V4, if V4 fails, you should have a good enough system to recover. And then the quickest way to recover is not fixing things in prod. Yeah, like all of us would have done it one or other time, but the best thing is roll back, figure out, and then go live again, right? IAC, infrastructure as a code, all of this Terraform, Chef, Kubernetes, and configuration management system all comes in here, because how much time are you going to take for replicating your whole architecture from one country to another? That's where the automation comes in, right? How much time, let's say one bad test is going to delete data, how much automation you have to recover from a backup. Let's say somebody just hacked into your system and then you want to kill things, like how much automation you have. Let's say worst case, everything is gone down. Like how much automation you have to bring up the VMs, bring up the services, bring up the code, like exactly everything you have. If you do everything manually, the recovery time is going to take days or even months, right? So that's where the automation and IAC helps a lot. That's why every company beyond architecture is going to be using like Terraform, Chef, and all of that, right? So this itself is a very different kind of a talk, and then all of the like a separate concept to talk about. So I think I sort of touched on multiple points. Like I just showed load testing in a high level because that gives you some sense to it. I'll also add on to it, right? Like the reason why I said Go is going to be brilliant is, like, I mean, at least it worked well for us. Is like one instance I can share, which is we sort of had a auth service. It's almost like the central piece of the whole ecosystem. And then we used to run like 30 VMs or 40 VMs to serve users. But after we rewrote it in Golang, our performance we sort of brought it down to like 5 VMs. And it's not just that, right? Like not just performance, the deployment time reduced drastically. Like Java used to take, I don't know, minutes. JRuby used to take like so many minutes, like 30 minutes. And like when I say 30 minutes, it's like if a single service takes 2 minutes to deploy, if you have a 30 VM, imagine how much time it's going to take to have a healthy service. But in Golang, it was like microseconds and stuff. And then the best part is like, whatever I have written, like I didn't have to use a fancy library or fancy external systems. The benchmarking, the profiling tools, the API, all was written like with default libraries. So, I mean, yeah, like here, ignore the semantics, but it's like everything is part of the HTTP library, and this comes in with this, right? So in that sense, the stack decision matters, right? Like Go might not work for everyone, but like somebody needs Rust because of a different reason. At some point or other, Java or like Python might not work for you, but you have to really ask that question. And then that's why people talk about like rewriting services or rewrite architectures, right? Because why would anyone go and spend so much time rewriting a particular service? Because beyond a point, after scaling your services, after scaling your architecture, you also have to relook at your decisions which you have taken long back, right? It could be anything like language, framework, stack, platforms, tools, and all of that. So in that sense, I think like, yeah, one takeaway I would say is take a point of these keywords, start with scaling your service. Like just be aware of these things, and then you can sort of associate it and then use it whenever you need it. You don't necessarily have to use sharding. I sort of left out a lot of things in observability, right? Like let's say after you have like resource anomalies, you have to have alerts. Then only you can act on it. Like I'm not going to sit and wait for like, let's say somebody to tell me something is wrong. Cover complete things, right? Tracing is another example where you have to figure out if I have 10 microservices doing a single API, how much is each API, each database call is going to take. All of that sort of comes in at a later point of time. But the point is, I think being aware of this framework, being aware of these things exist, I think will sort of help you in scaling your system is what I could say. But yeah, like I'll stop here and then I'll take questions and I'll probably close the call. Yeah. Any questions? If not, I can answer this one. Anything closely related to whatever we talked about with respect to architecture? If not, like we can talk about responsibilities. Anyone?
Yeah. So, in your example, how easy it was to link with Prometheus and Grafana?
Okay, so I think this is more specific, right? Like let's say the Prometheus and Grafana is just visualization. But let's talk about here, right? Let's say your service is there, and then you need to emit metrics. You can use influx of Prometheus, and then those are like time series database where you store it. And then Grafana is a visualization tool. Like that's where I was able to build dashboards and then stuff. this Influx or Prometheus, like how you integrate is just a library, right? Those enables you to send metric like gauge or counter, everything. But once you build your library, it could be like your own code, or there are a bunch of libraries which is out there open source. Yeah, even I have added something like just for showcasing, right? Like I was able to add servers, and then I was able to capture whatever you need. So in that case, I would say in Kubernetes world, Prometheus makes sense a lot. If you're in a VM world, Influx makes sense a lot. Like that's like a pull versus push versus pull model and all of that. That's again a different topic. But if you know what metrics to emit, like if I have to say one thing, it's like you shouldn't just look at your website is up. If you look at your each and every services, look at latencies and resource consumption, and then emit those metrics for every service, then that's a good starting point, right? Then link it with, let's say, business metrics. Every day you have to make 100 orders. If that goes down, there is something wrong. So it's really easy to integrate in that way. From client code perspective, it's not a lot. It's super easy, but let's say, yeah, I mean, it's not complex. It's very simple, I would say. Like if you haven't done any observability, you should look at it. It's super simple. Probably we can chat later on. I'll share more things.
Good, thanks.
Anything else regarding this event-driven stuff? Okay, awesome. Everyone is able to scale without pops up then. So
Hey,
I'll start. Sorry, go
sorry.
on.
Hi, this is Dave.
Yeah.
I had a question on the sharding. If you can go back to that slide, and I think you were saying very interesting thing that, you know, the customer data being sharded based on location or IP.
Correct.
So if that sharding is at the data level, how are we able to you know, redirect the request? Maybe I wasn't able to understand the use case. Are we saying that we are redirecting the request to that particular server hosting that database in that geolocation? Like what was that use case? Maybe you can repeat that.
Okay, so I mean, very simple use case, right? Like if you have a this whole, let's just say simple service, right? Hey, I have this whole service, which is like my ordering business, ride-hailing business in US and in Canada. Let's say there is two reasons, like more reasons also, right? Like there is a compliance reasons because of which a lot of companies will have to implement the data should stay within their own country, right? That's one. But like we are only touching on scaling perspective, right? Like in that case, in our sense, we want our latencies to be really small. And the other thing is, if you have a database, if you grow to 1 million customer, if each customer does order for 1 million order, if each order has, let's say 10 states, you're going to have 10 million states. And then for each of that state, if you have, let's say 5 transactions, you're going to end up with 50 million transactions in, let's say, per day. But imagine that for like, let's say 30 days. Imagine that for like 6 months, right? Your database is going to be really difficult to deal with, even though you have good indexing and all of that. Like, how do you optimize database for like so much load itself is a different topic. But the point is, rather than having 50 million records in a single database, it's going to benefit you if you could have 25 million in one database and 25 million in another database. And it could be just purely like a splitting it, which could help in performance, or it could be like a country level, right? Hey, in US, you have less customers. So this is sharded. And then any request, how do you figure out is basically like when you have a request, the request should have a metadata. It could be like a header, or it could be a post body, which has an IP, but you have to infer something from that particular request and then route it to appropriate shard, in this case, US region or Canada region. It could be as simple as IP address or a location, lat long, or it could be as simple as you take a user ID, you do a modulus, and then you route it to appropriate clusters. Just like how load balancer is able to route different requests based on APIs, you can also think about load balancer doing this sharding for multiple places. If it's database, you have to have different services, or your services have to keep that in mind and stuff like that.
Got it. Thanks.
Yeah, it's a very one-off cases where like some companies needs it, but it's definitely something like interesting to read about. Hope that answers like if not, like we'll chat later on. Anything else? Like anyone has any questions? For sharding, does both okay, again, the definition relies on the need, right? Like let's say in your case, this monolith and this database, you have never done any archiving. You couldn't scale it. So in that case, your database is going to lie in the same region. And you're going to shard. It's almost like just like this monolith, you're going to copy it and then paste it in another place. And then it could be same region or it could be different region. But as I said, when you think of this service, it's not usually going to be a single instance, but you're going to replicate this whole instance to a different region and then shard also in the same way. Yeah, hope that answers it. I think like if anyone have questions, do shoot. If not, I'll do a shameless plug. So basically, I am building a startup, and then I've been working on Kafka, and I've done a lot of DevOps work and stuff. So my objective is to basically like reduce if there is any issues. Like my personal experience with DevOps have been like super painful, like not happy vacations and whatnot. So in that case, I'm building a product. It'll be nice if somebody like if you want to sort of like if you can correlate to this, if you really need something, if something seems interesting, do let me know. Like we want some design partners. Yeah, that's just a shameless plug. Sorry about it. I'll sort like we'll stop here. Like it's really interesting to read about Byzantine tech general problem. It's very simple. Like hey, you have a fort. There are different people in a different location. They have to attack at the same time, but they don't have cell phones. And how do they communicate, right? They use a horse guy, like they use a messenger. And then the messenger could be killed in a war zone. How do you ensure there is this like synchronization which happens across everyone, considering things can fail? And the same concept sort of applies to synchronizing time across VMs. Like I think we don't give too much thought about it, but all of our laptops, the time is synchronized. How do we do it? The gossip protocols, like if you used columnar storage or any Paxos kind of application or stuff like that, these are like some sort of basics. Cap theorem also, like I think like when people say, hey, when you're writing a database, you have to know it, but I also feel like the same thing applies here. If you create multiple instances, it's possible that like your data is not consistent anymore. Like the architecture concept applies to the same way, right? Like if you have two different instances, and if you try to call it, again, you're going to have a same database to ensure consistency. But if you have a replication for failover, if something went wrong, you're going to fall back to the, let's say, previous setup. That means whoever did that setup, like within that latest time frame, is going to lose data. But you're more available, but you're not consistent. It applies exactly to the cases we have talked about. It's really good. Like the distributed systems paper, the Kafka paper, all of that I would suggest. Like there is a Go official paper of documentation you can read. I was able to generate heap allocation and all of that. Like I was able to do that with pprof. That's the what do you call that library internally. And then this library is really good if you want to read more about profiling specifically on Go. There is much more documentation, but I've used this even years back when there was no documentation for pprof. If you want to look at the metrics, I've pushed my code into Skillscape Go metrics. But apart from that, like feel free to sort of reach out to me if you need to like talk about anything, or like, I mean, I also organize like other meetups, like you'll be seeing me in Twitter or like somewhere posting about it, but happy to share more on like this topic, or happy to share more on like scaling in general or Kafka or a DevOps thing.